Hello, good day everyone. Welcome to our new episode of Math Tutorial, which topic is good for grade 10, Permutations and Combinations. Before anything else, let me present to you the objectives for this lesson. Here, we are to apply fundamental counting principle as you can see in our first lesson. Compute permutations, compute combinations, and distinguish permutations versus combinations. Let us recall that the fundamental counting principle can be used to determine the number of possible outcomes when there are two or more characteristics, alright? As you remember that. And the fundamental counting principle states that if an event has m possible outcomes and another independent event n has n possible outcomes, then there are m times n possible outcomes for the two events. For example, for a senior high entry view, Jansen has to choose what to wear from the following: 4 slacks, 3 shirts, 2 shoes, and 5 ties. The question is, how many possible outfits does he have to choose from? Okay, based on our counting principle, you just have to multiply all these events: the slacks, the shirts, the shoes, and the ties, the number of the slacks, the shirts, and so on. So you have here 4 times 3 times 2 times 5. So he could have 120 outfits or ways to choose an outfit. So we'll move on to permutations already, since we have already our counting principle the last time. We even have a video for that. So permutations, or by definition, a permutation is an arrangement of items in a particular order. So it's arranged in a particular order. And notice that here order matters. Here again, order matters. This is the term that we need to remember. To find the number of permutations of n items, we can use the fundamental counting principle or factorial notation, the one that we discussed in the previous video, principle of counting and the factorial notations. You know now where to use it. It's permutation and combinations. So you have an example here under permutation, the number of ways to arrange the letters A, B, C. Okay, so there is order because you are going to arrange the letters A, B, C. Now, you may do it this way, wherein you can write 3 blanks in your paper and that you are going to choose what letter is for your first blank, what letter is for your next blank, and for the third blank. Okay, here you can do it this way. Well, in your first blank, your number of choices is 3. That's why it says here number of choices for the first blank is 3. Then how many number of choices, or what is the number of choices for the second blank? Of course, you have 2, right? 2 letters left. And then for the third, you have only 1 letter left. That's why your number of choices is 1. You can do it you can check it using your counting principle. 3 times 2 times 1, that's equal to 6, meaning there are 6 possible ways. And then you can also employ the factorial, 3 factorial, since there are 3 letters. Then you have 3 times 2 times 1 equals 6. That means 6 ways. Or you may write it, all of the combinations of after you arrange all the letters, you can write it just like this, and it will show that you have really 3 choices in the first, 2 choices second, and 1 choice for the third letter. In permutation, to find the number of permutations of n items, choose an r at a time, you can use the formula. This is just you can read it: permutation of n taken r at a time. Okay, permutations of n taken r at a time, okay, is equal to n factorial over the quantity of n minus r factorial, where r here is greater than or equal to 0 but less than or equal to n. So it should not be greater than n. Okay, that's not possible. But anyway, here, for example, you have n given as 5 and r given as 3. So you apply it in the formula. The permutation 5 taken 3 at a time, you have this 5 factorial over 5 minus 3 factorial. Therefore, you have 5 factorial over 2 factorial. The 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. So that is why you have 5 times 4 times 3 is equal to 60. Okay, is equal to 60. So this gives you the answer. So why is it 5 times 4 times 3? Where is 2 times 1? Okay, it's being cancelled out. Okay, being cancelled out since 2 factorial is also 2 times 1. So 2 times 1 above and 2 times 1 below is cancelled out. Turns 1. Here's a problem. A combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive is selected. So it can be opened using 3 numbers. Okay. How many different lock combinations are possible, assuming no number is repeated? No number is repeated. So there are 30 numbers to choose from, and you are to pick only 3 numbers for the combination. So the question is how many different lock combinations are possible, assuming no number is repeated. So ang daming itatry natin. So for that, you have permutation of 30 taken 3 at a time. So you have 30 factorial over 30 minus 3 factorial. That you have 30 over 27 factorial. Why 27? Because that's a 30 minus 3. Okay, then that you have 30 times 29 times 28. Because 27 down below, down to 1 is already cancelled out. Then if you multiply 30, 29, and 28, that would be equal to 24,360. So these are the number of possible ways or combinations that you can have if you are to select 3 from 30 numbers. Let's continue with another practice problem. From a club of 24 members, so there's a club, 24 members, meron ito. A president, vice president, secretary, treasurer, and historian are to be elected. Okay, how many ways can the office be filled? How many ways? So from the 24 people, you are to elect president, vice president, secretary, treasurer, and historian. Okay, so you can have that in permutation. Why is it permutation? Because order is important here. How did we know? Because the different offices, president, vice president, secretary, treasurer, and historian are not of the same order. Okay, are not of the same order. So the order is from president followed by vice president. So there's really the order really matters here. So from that, we knew it's permutations of the permutation of 24 taken 5 at a time because there are 3 offices that we are to fill out. So it's equal to 24 factorial over 24 minus 5 factorial, and that you have 24 factorial over 19. And what remain here is the 24 times 23 times 22 times 21 times 20, because 19 and below is already cancelled out. The result is a 5,100,480 ways. Okay, and dami. Okay. A large number to, the ways how to choose so that the offices will be filled. So let us now proceed to combinations. A combination is an arrangement of items in which order does not matter. Again, order does not matter. Since the order doesn't matter in combinations, there are fewer combinations than permutations. The combinations are subset of permutations. To find the number of combinations of n items chosen r at a time, you can use the formula NCR, but that's you're going to read it. The combination of n choosing r at a time is equal to n factorial over r factorial times the quantity n minus r factorial, where r is greater than or equal to 0 but less than or equal to n. Given that formula for combinations, for example, you were given n is equal to 5 and r is 3, so you will apply the formula. Then you have the combination of 5 choosing 3 at a time is 5 factorial over 3 factorial times the quantity 5 minus 3 factorial. which you will have then 5 factorial over 3 factorial times 2 factorial. That you are going to have it further. What is 5 factorial? That's equal to 5 times 4 times 3 times 2 times 1, and 3 factorial is equal to 3 times 2 times 1, and 2 factorial is equal to 2 times 1. What remains here is 5 times 4 over 2 times 1, since the 3, 2, 1 is cancelled out. And 5 times 4 is equal to 20, 2 times 1 is equal to 2, and that 20 over 2 is equal to 10. Therefore, your answer here is 10. So there are 10 combinations. So here's a practice problem. To play a particular card game, each player is dealt 5 cards from a standard deck of 52 cards. How many different hands are possible? So you'll be looking for how many possible hands would there be given the situation. So here order is not important. It does not matter since all players will receive the same number of cards. So 5 cards, okay? Because the problem is just asking us how many hands are possible. Okay, now to solve that, you will take 52 as your N and 5 as your R. So you have the combination of 52 taking 5 or choosing 5 at the time. You have 52 factorial over 5 factorial times 52 minus 5 factorial, which is now 52 factorial over 5 factorial over 47 factorial. And that you have 52 times 51 times 50 times 49 times 48 over 5 times 4 times 3 times 2 times 1. Where is 47 below? It's already cancelled out since the denominator is having 47 factorial. That when you're going to multiply, you can get the product 2,598,960 possible or different hands that you can deal the cards. Let us take another problem. A student must answer 3 out of 5 essays, a question on a test, for example. In how many different ways can the student select the questions? So the student is just to choose 3 out of 5. Usually our teacher is giving that. Okay, you pick 3 questions only from 5 questions that I give. Okay, so the question here is how many different ways can the student select the questions? So you have the combination of 5 taken 3 at a time because 5 essays or items, and you have to choose 3 items only. So 5 factorial over 3 factorial times 5 minus 3 factorial. That you have 5 factorial over 3 factorial times 2 factorial. And that would be 5 times 4 over 2 times 1, because 3 below 3 times 2 times 1 is already cancelled out, and what remains is 2 factorial. That's equal to 10 since 20 over 2 is 10. So there are 10 different ways the student can select the question. Okay, let's take this last problem here. Okay, it seems like harder compared to the others. Now, a basketball team consists of 2 centers, 5 forwards, and 4 guards. In how many ways can the coach select a starting lineup of 1 center, 2 forwards, and 2 guards? Here it's still the same. Order is not important because they are all players. They are just assigned to their certain positions, but they are all equal players. Now they are players. So the coach is to select a starting lineup. There are 2 centers. If you're going to count all, how many players are there in the team? 2 plus 5 is 7, plus 4 is 11. So there are only 11 players here in the team. And the problem is how many ways can the coach select a starting lineup? 5, that is composed of 5, right? 5 players. There should be 1 center, 2 forwards, 2 guards. So here the solution, we are to separate the number of combinations for the center, the number of combinations for the forwards, and the number of combinations for the guards, and that you are going to multiply after. So for the center, since you are to choose one from 2 centers among 11 players. So you have combination of 2 taken 1 or choosing 1 at a time. So you have 2 factorial over 1 times 1, 1 factorial times 1 factorial. That's equal to 2. Okay. For the forwards, you have 5 take chosen 2 at a time. So 5 chosen 2 at a time. So 5 factorial over 2 factorial times 3 factorial. And why 3 factorial? That's 5 minus 2. Okay, 5 minus 2. And that you have 5 times 4 over 2 times 1 because 3, 2, 1 is cancelled out already. Thus, you have 20 over 2 or 10. Okay, 10 um, 10 ways the coach can select forwards. Here, 2 ways the coach can select centers. For the guards, 4 taken 2 at a time or chosen 2 at a time. So 4 factorial over 2 times 2. Why 2? Because it's already 4 minus 2. So 2 factorial. Then you have 4 times 3 over 2 times 1. Why 2 times 1 only? Because the other 2 times 1 is cancelled out due to the numerator 4 times 3 times 2 times 1. So 2 times 1, 2 and 1, 2 and 1. One pair of 2, one pair of 1 cancelled out. And then you are going to multiply the results. 2 times 10 times 6, we have 120, meaning there are 120 ways. So the coach would have 120 ways to select the starting lineup for his team. I think that's it. Thank you for watching. I hope you learned something from the video. God bless.